Hey fellow problem solvers, Colfax Math here. Today we're going to do lesson number 4 on our Hesi preparation math exam. In this video we're going to go over a few different things: absolute numbers, rational and irrational numbers, square roots and cube roots, scientific notation, and factorials. If you want any more help or support, you could get this app right here at the App Store or on Google Play, or here's the web address as well. So what I'd highly recommend you do with this is that you have a notebook out in front of you. You pause the video, do the problem before I do it, unpause the video, and then watch how I do it. Take some notes down as well. You might want to put notes in a separate area. But the only way to really learn math is by practicing. Right? I could explain how to juggle, but you're never going to learn until you practice. I could explain math, but you're never going to learn until you practice. So I have a sample test here. Again, pause the video. We'll work our way through this test. I'll give you some tips and tricks and also explain the ideas as well. So with that said, let's go ahead and get started with your notebook and pencil. Pause the video, do this problem, then unpause it, and then watch how I'm going to do this problem. So this problem right here is all about absolute values. And what that really means is it's a distance. So the bars up and down like this mean everything inside of those bars becomes positive. So if I had -6 absolute value, that just means 6. It wants to know how far away you are from a point. So if we were on our number line and this is 0 and this is -6, how far is that to 0? And that's what absolute value does. So let's take a look at this problem right here. I'm going to keep that first negative out front. And then I have -3 in that absolute value. That becomes positive. Then I have this negative out front. That's this one. Absolute value of -12 becomes 12. So I've gotten rid of the absolute values by making those numbers positive. And then from there, the way I remember these is I think a -3 plus a -12. So this is the same thing as plus a -12. And then -3 plus -12 is -15. Correct answer, answer B right there. Okay. Number 2, in the sequence above continues, we got a pencil going here. If the sequence above continues as shown, what is the sum of the first 66 terms? So that means we have 1, 2, 3, 1, 2, 3, 1, 2, 3. So the sum of 1, 2, 3 right here is going to be 6. The sum, adding all the values up, is 6. The question is saying, can you add 1 plus 2 plus 3 plus 1 plus 2 plus 3? So the first thing you have to do is figure out what that sequence is. How many of these 1, 2, 3s am I going to have? Well, in 66 terms, I have 3, so I'm going to do 3 in a 66 to get 22. So I have 22 of these groups of 3, right? So that's saying I have 22 that add up to 6, or 22 times 6 will be 12. Carry the 1, 13, 132. Correct answer, answer D right there. Okay, number 3. So again, pause the video, do the best you can right here. And this is really a vocab question. Which of the following is not a rational number? The definition of a rational number is that you could represent it as a fraction where both the numerator and denominator are integers. Integers are whole numbers. So this is a rational number, and the irrational number is one that can't be represented like that. So 1/2 is rational, pi is irrational, 0.38 means that 8 just keeps repeating, so just 8 all the way down, like that. And then root 64 is equal to 8. So that's the square root of a rational number. So which of the following is not rational? So that's saying which one is irrational. The only one that's irrational is B right here. Okay, number 4 right here. Which of the following is not an irrational number? That's actually a double negative, so it's saying which one is a rational number. So remember, definition of rational is you can represent a fraction with the top and bottom both being integers. So if we look at this right here, and I don't really want to do all of this math and figure it all out, all 3 of these have something in common. This is called the cube root of 169. This is the 4th root, and that's the 5th root. This right here, 169, if you don't recognize it, is 13 squared. So that's just going to be equal to an integer, which is a rational number. So I could go right to that one and say correct answer D and not have to figure out those first 3 numbers. Okay, so 4 is D. Okay, and then number 5, we're moving into scientific notation. So how scientific notation works is you're going to take whatever number it is, you want the tens place and the tenths place. So you want a value between 1 and 10, and then you're going to multiply it by 10 to some power. Just the way you represent really large numbers or really small numbers, and the exponents a negative. So if it was 0.000003, rather than having to write all of those zeros in the front, you would say 1.3 times 10 to the negative 5 or whatever it is. If it was a really big number, like 13, right, you would just count up the zeros and turn it into 1.3 times 10 to the 1, 2, 3, 4, 5, 6, 7. So right here it says express 3,750,000 in scientific notation, so we know it's going to be 3.75. 3.75, I got to put the decimal over 1, 2, 3, 4, 5, 6. So it's going to be times 10 to the 6. Correct answer, answer A. Okay, another scientific notation problem here. This one is, like I was saying, is negative. So first thing you want to do, pause the video and do this problem. And then let's go ahead and do it. So it's going to be 4.5. So to get the decimal over there, I got to go over 1, 2, 3, 4, 5, 6. So I got to go over to the left 6 times. So it's 4.5678 times 10 to the 6 right there. Correct answer, answer A. Oops. Calculate and express the result in scientific form. Okay, so we got to multiply these 2 numbers together. And really all we're going to do is we're just going to look at these numbers first, and then we'll figure out the decimal place after that. So I got 54 times 32. That's going to give me an 8, 10. My placeholder, 3 times 4 is 12, carry the 1, 16. So it's going to give me 8, 2, 7, 1, 1728. So it's going to be 1.728. I look up there, the only answer I can eliminate is D. Then let's see here, this is going to be 3.2 times 1, 2, 3, 4. So we had 3.2 times 10 to the negative 4. And this is going to be 5.4, 1, 2, 3, 4, 5, 6, 7. 5.4 to the 7th. Okay. We did that 3.2 times a 5.4, so let's do that. 5.4 times 3.2, the decimal place is over 1, 2, so it's 1728. I don't know where that made a mistake there. So 1728. Then I'm going to add these exponents together to get 10 to the third, right? So it's 17.28 times 10 to the third, but this has to be between 1 and 10, so I got to move it over 1 to get that 1.728. If I'm going to move this over one place, I got to move this over one place as well. So it's 1.728 times 10 to the fourth. Answer A right there. It's a pretty hard problem. I kind of used a lot of different techniques. Some of them to save time. I could have done all that long multiplication, kept track of all those zeros and filled the page up with zeros. But instead, I decided to convert it to scientific notation first, and then figure out what this times this is, which was the 17.28, and then what the tens are. The rule on these exponents right here is if I have the same base, like x times this, so I have the same base, different exponents, it's being multiplied, I add the exponents to get x to the seventh. And that's why I added my exponents here, to have the same base number. All right, question number 8. Simplify the square root as much as possible. So how a square root works, maybe don't pause the video yet if you can't quite remember this from school. Right? These aren't really lessons as much as review. Hopefully you saw this before. So how square roots work, it is saying the square root of 25 is saying what times itself equals 25. So I look at the factors of that number. The only factors are a 5 and a 5. For every pair, 1 comes out. So the square root of 25 is equal to the pair of 5s inside or 1 outside. So the square root of 75, I'm looking at the factors of 75. Well, 75 is made up of a 25 and a 3. A 25 is made up of a pair of 5s. I brought it all the way down to primes. For every pair, 1 comes out. So here's a pair of 5s. 1 comes out. There is no pair for that 3, so it stays in. So root 75 can be reduced to 5 root 3. So correct answer is answer B. The check here is if I want to put this back into the square root, I just square it. So 5 squared is 25. 25 times 3 is 75, which gives me the original square root of 75. Okay, simplify the square root of 169y squared. So bring that thing down to pairs. Pause the video. Do the best you can on it. And then unpause the video and check your work. So we're going to bring that thing down to whatever the roots are. 169y squared. 169 is made up of a 13 and a 13. That's a pair. Y squared is y times y. Remember I was talking about if you have the same bases, you add them together. So y to the first times y to the first gives me that y to the second. So I've broken everything on the square root into pairs. For every pair, 1 comes out. So there's a pair of 13s, 1 comes out. Here's a pair of y's, 1 comes out. There's nothing left inside, so that's as far as you could go. Problem number 10. If you're new to the channel, think about subscribing, hitting the notification. Please feel free to share these videos with anybody you know who might be studying for these exams. Okay, this one's a little harder. We have 4 radical x is equal to 56. It's an equation with an equal sign. I have to get x by itself. First thing I'm going to do is divide both sides by 4. That's going to give me radical x by itself. On the left, 56 divided by 4, I think is that 14? 4 goes into 50 once, 16, so it goes in there 14 times. 40, 56, so it's 14. This, to get x by itself, I have to square both sides. So I have to square both sides. A square removes a square root. I do whatever I want as long as I do it to both sides. That's going to give me x by itself. 14 times 14 is 196. Correct answer, answer D right here. Okay, problem number 11. Determine the cube root of 512, negative 512. Negative 512, what a cube root is a square root with a 3 right here. So we want to know the cube root of 512. It's a negative number, so a negative times a negative times a negative is going to give me a negative. So the only thing that's going to work up here is it's going to be a negative 8, right? That's the only negative value. So negative 8 times negative 8 is going to give me positive 64 times another negative 8. It's going to give me a negative number. I guess it'll be 512. My pen's going slow, so it'll be negative 512. So a cube root is what times itself a third time equals that. It's a pretty hard problem when you look at it, but when you look at those multiple choice answers, the only one that makes sense is answer D, negative 8. Okay, number 12, problem number 12. So what we have here is we have the cube root of y plus 10 equals 12. Again, what we're trying to do here is get y by itself. So I'm going to subtract 10 from both sides to get the cube root of y, 12 minus 10, is equal to 2. So what times itself will go in here to equal 2. Well, the 7 and the 9 don't even make sense. Let's try an 8. If I were to plug an 8 in here, 2 times 2, 4 times 2 is 8. So I could see the cube root of 8 is equal to 2. So the correct answer, answer B, right there. Problem 13, we're getting closer here. Evaluate the expression. Those things right there are called factorials. So what a factorial is you multiply down from that number. So 3 factorial is equal to 3 times 2 times 1. It doesn't mean 3 with emphasis. It means multiply all the way down. So I'm going to write that out up above. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1 over 4 factorial, 4 times 3 times 2 times 1. Those cancel, those cancel, those cancel, those cancel, leaving me with 6 times 5, or 30. Correct answer, answer B, right there. Okay, problem number 14. How many floorboards, 2 1/4 inches, I'm going to highlight the inches, are needed to cover a floor of 15 feet wide? So I got 2 different types of units. So I'm going to take this 15 feet and turn it into inches. 12 inches equal 1 foot. So 12 inches to the foot. 2 times 5 is 10, carry the 1, 3, placeholder, 5, and a 1. So 15 feet is 180 inches. Now the question is, how many times does 2 1/4 go in a 180? Well, 3 will go in a 180 60 times. 2 will go in a 180 90 times. Let's take a look at the answers up there to see the values between 60 and 90. The only ones that are going to work are A and C, right? But 2 1/4 is closer to 60, right? This is our 2. No, it's not. 3, if it's 3 inches, it'd be 180. If it was 2 inches, it would be 90, right? So we're closer to this amount, so we're going to have to be closer to 80. That makes sense. Kind of went through that a little quick. So I have a total of 180 inches. I'm just going to round down to 2. 2 goes in a 180 90 times. If it were 3 in a 180, it would be 60 times. I look at my answers up there. 70 and 80 are the only 2 in between here. This is the number of boards I would need if it were 2 inches. 2 1/4 is closer to 2. So I'm looking for, of those two, the one closer would be 80 inches. Correct answer, answer C right there. Okay, problem number 15. A 2-pound walnut pack costs $38.40. What's the cost of a 6-ounce pack? Well, let's break this down to the price per pound to start with. So 2 pounds is $38.40. Let me just cut that in half. Half of 38 is 19. Half of 40 is 20. So it's $19.20 per pound. I don't want a whole pound. I only want 6/16 of a pound, right? Because there's 16 ounces in a pound. I know these measurements are a little tricky, but we're in ounces here, and I have, this is what I want over the total. Let me see if I can reduce some of these numbers here. 2 will go into here 3 times, 2 will go into here 8 times. So I want 3/8 of 1920. See if I can figure it out from there. You know, half is going to be less than 10. It's too hard to figure out, so we're going to have to do the math on this one. So I'm going to take 1920, multiply it by that 3, and then divide it by that 8 to get 0, 6, 27, carry the 2, 5, 57, 60. Then I'm going to divide it, that 5760, by 8. I'm going to divide that by this 8 there. 8 goes into here 7 times to get 56. 1.6. See if I can figure it out there. There's still 2 possible answers. 8 goes into 16 twice, so I could see it has to be the 720. So correct answer, answer C right there, $7.20. That was a hard one to end it on. If you want any more help, you could go to the App Store right here and pick up this app or the webpage. A lot of other sample tests you can find there. If you have any questions, post them in the comments. I'll try and get back to you as soon as I can. I appreciate you watching. Thank you for your support. Hit that like button and comment. Well, hit that like button only if you liked it. Thank you.